What's up, y'all? Gordias here. This is the video for systems of linear inequalities. So, let's get to it. With the system of linear inequalities, you might have two, you might even have three inequalities, and that's fine. But what we're going to do is we are going to solve these by graphing them. And the reason why is inequalities already naturally have a ton of solutions. So because of that, because they have multiple solutions that can satisfy inequalities, a system of linear inequalities is also going to have multiple solutions that can satisfy both inequalities. And we'll show what that means. So the first thing we're going to do is I'm going to look at my system, and what I'm going to do is I'm going to graph these both on the same coordinate grid. So I'll do this one, first one, we'll do this one in red. I'll mark my red right here next to it. So I have y is greater than x minus 2. So I do need to know how to graph linear inequalities. If I don't do that, go watch that video. That's the one I posted right before this one, because that is the, you have to know how to graph these separately. So if I graph y is greater than x minus 2, I'm going to start at negative 2, my y-intercept. My slope is just 1, so up 1 over 1, and pretty simple. I also have to determine if I have a solid or dashed line. And because there is no or equal to, it is a dashed line. So there's my first graph. And now what I need to decide is I got to decide which way I would like to shade. Okay, so y is greater than. So I can probably going to be shading above, but let me test a point, any of these points up here, to see if any of these points is a solution to my inequality. And I can always test 0, 0. Okay, 0, 0 is my favorite point to test because it takes the least math. Because if I plug this in, is 0 greater than negative 2? Yes, it is. So by testing that point, I know that 0, 0 is a solution to my inequality. Because 0, 0 is a solution to the inequality, that means that every single point above the line is a solution to the inequality. So I'm shading, this is just lightly with my pencil. I'm using a nice highlighter because it looks nice. All of these are the solutions, I don't want to do that, to this particular inequality. So I just graphed the first one. Now what I'm going to do is I'm going to graph my second inequality, and I'll do this one with blue. Okay, so I have my first one. This is my first graph, my first inequality on my graph. Now I'm going to do my second one. Negative x plus 1, so I'm going to start at positive 1. Negative x, so this is down 1 over 1. And this one is a solid line because it has the or equal to. So I gotta see if I can try to draw a straight line here. Missed it in the beginning. Whoa, I missed the line with dots completely, but at least it wasn't the worst line ever until I just made it worse in the end. So there we have it. So I have my second line here in blue. Now I've also got to do the shading for that line as well. So, oh, that's not what I want. There we go. So when I do my shading here, I got to figure out if y is less than this line. So if I got to check a point. I'll check 0, 0 again to see if 0, 0 is part of the solution set to this particular inequality. So I have 0 is less than or equal to negative 0 plus 1, which is just 0. So 0 less than or equal to 1. Is this a true statement? So I took the point 0, 0 to test to see if this side is a solution side for that particular inequality, and it is. So that means I can start doing my shading here. Now, what do we notice? Okay, this is what I want you to look. So I'm doing my shading for this particular inequality. Okay. So I have the solution to this inequality here. I have the solution to this inequality here. So my solution is really this overlapped section. And you can see it's a different color because I overlapped it twice. So this whole section right here is a solution. Now, do you need to draw this line that I just drew for your solution? Absolutely not. I was just kind of pointing it out to you. But that section right here is my final solution for the systems of inequality. So what that means is if I pick any single point that is in this section that's been shaded by both, that's the overlap. If I pick this point, any of these points right here, okay, any point, that means all of those points would be a solution to both of these inequalities. They would make both of these inequalities true. Okay, so my final solution is this. So I would just leave my graph as such, and there you have it. A couple things to notice is you need to be careful when we shade, and we'll talk about that in this next slide. So to graph systems and linear inequalities, graph each inequality on the same graph. Make sure to do your shading lightly with your pencil. So when we graph our first one, we want to shade lightly. When we graph our second one, we want to shade lightly. That way we can see the overlap. Once we see the overlap, that is our solution. And that section, we need to shade just a little bit darker so it pops out and we can see what the actual solution to the system of inequalities is. Okay, so make sure we get these down, and let's try some more. So again, I have another system. Y is greater than or equal to negative 2x plus 1. So let's just start with that one. And again, let's graph this one. I'll do this one in purple. Okay, so I get positive 1, negative 2x, down 2 over 1. Sweet. Up 2 over 1. So the graphing them should be pretty quick and easy. This is a solid line. Oy, not terrible. Okay. So now let's do and then now I got to figure out which way to shade. Okay, that's the big thing here. So y is greater than negative 2x plus 1. So it's probably going to be above the line, but let me test a point just to make sure. 0, 0, I'm not really sure what side of the line is because of my bad graph here. So I'm just going to test this point right here because that's clearly above the line, and that's the point of 2, 0. Okay, so 2, 0. So I'm going to test that point. So I'm going to see if this point is a solution. Negative 2 times 2 plus 1. So that's negative 4 plus 1, which is negative 3. Is 0 greater than or equal to negative 3? The answer is yes. So that means because this is part of the solution, that means this whole side of the graph is a solution. So all of these points are solutions to that single inequality. Now I've got to I have to graph my second inequality. Y is greater than x plus 2. Start at positive 2. Y is greater than x plus 2. And so my slope is 1, so I'm going to go up 1 over 1 like so. But because y is greater than, I've got to not use a solid line because there is no or equal to, and so it is a dashed line. So there's my dashed line. Boom, boom. All right. And then now I got to figure out if 0, 0 is a solution. I just got to figure out if it's above the line or below the line. Y is greater than, so I'm thinking it's going to be above the line, but I'm not positive, so let me check 0, 0. 0 is greater than 0 plus 2. Is 0 greater than 2? No, it is not. So that means this is not a solution to this inequality, which means that everything on the opposite side of the line of that line is. So that means everything above this line is the solution to my inequality. Now, hopefully we can clearly see the area in which the overlap is. It is just this area right here. And so we could shade this in a little darker if we needed to. Okay, this is where I'm gonna take my pencil, maybe shade it in a little bit darker to make this really stand out. Doesn't have to be crazy dark. No, we just want to make sure that it's clearly easy to see where our solution is. All right? Try this one out on your own. I want to see how you guys do and see what you guys come up with. So try this one on your own. Okay, so I got a joke for you real quick. What did the 0 say to the 8? So what did the number 0 say to the 8? Nice belt. You get it? An 8, it's a 0, but its waist is super tight because of its belt. Okay, anyways, it's awesome. All right. So for this graph right here, I'll do this first one in orange, negative x plus 2. So there we go. And it's or equal to down 1 over 1. I almost made a mistake there. So that means I can use a solid line. And again, sorry for my lines being super not straight, but it is what it is. Okay, y is greater than or equal to. So again, I'll test 0, 0. Is 0 greater than or equal to 2? No, it is not. So therefore, everything on the opposite side would be a solution. So it should have been up here. Okay. Now I have y is less than negative x minus 2. So negative 2. This is negative x as well. So we have the same slope. So if we notice, I have parallel lines here. Okay. So that's interesting. This is or equal, no or equal to, so it's a dashed line. All right. And now y is less than. So again, I'm going to test 0, 0 to see if that is a solution to this particular inequality, to see what side of the line I shade. is 0 less than -2? The answer is no. So that means 0, 0 is not a solution, so nothing on this side is a solution. So that means everything underneath is a solution. So if we notice, there is no overlap. So if there is no overlap, these lines are parallel lines, they're the same slope, so these solution sets are never going to have anything in common. So therefore, the answer to my system of inequalities is just no solution. There is no ordered pair that exists that would make both of these inequalities true. Okay, so this is your last example. So go ahead and give this one a shot, pause the video, and then check to see how you did afterwards. Now, this system, they are not in slope-intercept form. That is okay. You have two options. You can graph them in standard form, because that is totally fine, because these are actually pretty easy to graph from standard form. Or you could just convert them to slope-intercept form. Me, I'm going to graph them in standard form because that is going to be pretty simple. So if I plug in 0 for my y, I'm going to graph by using my intercepts, I should say, not graph in standard form, but I'm going to graph by using my intercepts. I'm going to plug in 0 for y, because if I plug in 0 for y, that means I'm finding my x-intercept. So if I plug in 0 for y, that just goes away. So I have 2x is greater than or equal to -6, divide by 2. So I have x is greater than or equal to -3. So what that means is my x-intercept is -3. I can do the same thing for my y-intercept, and just so you know, since it's the same number I already know, it's going to be -3. So I have a solid line going through these 2 points. So there we have it. And now I just got to figure out if it's above or below the line. So I'm going to plug in the point 0, 0, because I can just test it to see if this side is a solution or this side is a solution. When I plug in 0, 0, I'm just going to get 0 is greater than or equal to -6. I plugged in 0 for x, 0 for y. Is this a true statement? Yes, it is. So therefore, this side is my solution set. Okay. And then finally, we have to do the same thing for this second one here. Just because I'm guessing a lot of people did this, I'll subtract x from both sides to show you how to graph them in 2 different ways. And I could have had y is less than or equal to -x minus 1. So now I can just go ahead and graph it starting at -1. And it's -x. It looks like these are parallel lines. And again, it is a solid line. So I have another set of parallel lines. Interesting. Well, they're supposed to be parallel, but when you can't draw a straight line, they may look a little funky. Now I want to see y is less than, so I'm guessing it's going to be below the line, but I'll test the point 0, 0 to see if that's true. So 0 is less than 0 minus 1. So 0 is less than or equal to -1. Is this a true statement? I tested 0, 0 for this purple line. No, it is not. So therefore, this side is not the solution. So it's everything below, which means our solution, some of you can already tell, is going to be everything that's in between the lines. Okay, so this overlap is right in between the lines. So let me actually see if I can shade this a little bit better for you guys. Everything in between my parallel lines is going to be my solution. Okay, so I shaded it nice and dark in there, and there's my final solution set. Okay, and that's it, guys. So graph both on the same graph. Wherever they overlap your solutions, that is your final solution. Thank you for watching this video. If you have any questions, please let me know. G out.